So my equation is f of x equals arctangent times 2 of x. And I rewrote it as y equals the inverse of tangent times 2 of x, so that would be a little bit easier to work with. First of all, we know that the derivative of arctangent equals 1 over 1 plus x squared. But we want to know how we got to that conclusion. So first, we're going to multiply each side times tangent. And that's because we want to get this, our x, all by itself. So we have tangent times y, and then tangent times the inverse of tangent times 2 over x. And this is going to stay the same, so we have tangent y equals tangent and its inverse are going to cancel because they are opposites. So we are left with 2 over x. So we have tangent y equals 2 over x. And we're wanting to find the derivative of each side. So we have d over dx times tangent y equals d over dx times 2 over x. So now we find the derivative of both sides. So the derivative of tangent we know is derivative of tangent equals secant squared x. So we have secant squared y because we're still working in terms of y, and we're going to do implicit differentiation because it works with equations with x and y on the same side. So we have dy over dx, and that's going to equal the derivative of 2 over x. And for the derivative of 2 over x, we're going to want to use the power rule. So 2 over x is equal to 2 times x to the negative first. Negative 1 times 2 is negative 2. And then negative 1 minus 1 is negative 2. So the derivative of 2 over x is negative 2 times x to the negative second. And then now what we want to do is get this by itself. So we're going to divide by secant squared y on both sides. So we have dy over dx equals negative 2x to the negative second over secant squared y. Now we have to relate secant squared y back to tangent y. And to do that, we're going to use a Pythagorean identity. So we have sine squared x plus cosine squared x equals 1. And we want to make it relate back to tangent y. So we're going to divide by cosine squared x on both sides. Keep forgetting to write my s. There we go. And this is going to equal tangent squared x because sine over cosine is tangent, plus 1 because cosine over itself is 1. And then 1 over cosine is secant. So it's going to be secant squared x. So we have secant squared x equals 1 plus tangent squared x. But we're still working in terms of y, so we're going to rewrite it as tangent squared y plus 1. And we're going to keep our numerator. But this is going to be our denominator. But we're going to rewrite this because tangent squared y is the same as tangent y squared. We're going to rewrite it as tangent y squared because it will be easier to work with. So we have negative 2x to the negative second over tangent y squared plus 1. And at the beginning, if we refer to the beginning, we see that tangent y equals 2 over x. So we are going to plug 2 over x in for tangent y. So we have negative 2x to the negative second over 2 over x squared plus 1. And now all we have to do is simplify. So we're going to start with simplifying the denominator. So 2 over x times itself, because it's 2 over x squared, is 4 over x squared. And it's 4 over x squared plus 1. And then we're going to simplify the numerator. So negative 2 does not have a negative exponent, so it stays on the top. However, x does have a negative exponent. So x is to the negative second power. So we're going to bring x down to the denominator. So x squared times 4 over x squared is 4. Well, x squared times 4 over x squared is 4. And then x squared times 1 is x squared. And we keep the numerator. So the derivative of arctangent times 2 over x is negative 2 over 4 plus x squared.